All right, well, hello. My name is Evan Reese, and on behalf of the U.S. Resiliency Council, I want to welcome you all to the Resilience Advantage webinar series. The USRC is a nonprofit organization founded in 2011 with the mission of improving community resilience one building at a time. Our vision is a truly sustainable world where we not only have a low impact on the environment has a low impact on us. Through our building performance rating systems and educational programs such as the Resilience Advantage, we work to motivate all stakeholders in the built environment to pursue, invest in, and reward resilient building design. The USRC has nearly 100 members in the engineering, architectural, and construction industries. To start, it gives me great pleasure to introduce Ali Sahabi, co-founder of Optimum Seismic and a leader in the sustainability and resilience movement. I began working with Ali and our first major partner, the Los Angeles County Business Federation, to deliver educational programming for businesses on resilience issues in 2017. We've held many in-person seminars and live stream programs in the past, but COVID obviously has led us to a format that we have today. Ali's been a leading sponsor of the USRC for 4 years, and his generosity and that of Optimum Seismic has really made this series possible. So Ali, thank you for your sponsorship of this event and the support of all we do. Can you just tell us a little bit about your interest and your passion for the resilience movement?
Thank you. Thank you so much. Hello, ladies and gentlemen. Thank you, Evan, for your introduction. And on behalf of Optimum Seismic, I am very proud to sponsor this series, the Resilience Advantage, this 12-part educational webinar series. You're right, Evan. I'm very passionate about the need for businesses to become more resilient. You know, for more than 30 years, my professional commitment has been to sustainability and resiliency. And I truly believe that now is the time to act on resiliency, not tomorrow, not in the distant future. We are at a tipping point. We know how to minimize damage from major earthquakes. We know it's cost effective and practical. We know it can benefit both the new and existing buildings. That is why we're working with U.S. Resiliency Council to produce this series, the Resilience Advantage. At this time, I really want to take this opportunity to thank you, Evan, for your leadership and your willingness to really tackle this with us several years ago now. If it wasn't for your enthusiasm and your really willingness to take this on, we couldn't have accomplished what we have up to now. And I'm really looking forward to continuing our relationship with you and your team, some of whom we're going to meet as we go forward with the series. With that, you know, before, as you know, before we start the program, I would like to thank our major partners, organizations who have joined with us over the years to focus attention on the vital message of earthquake resilience for our business community. Those organizations, our major partners, are Los Angeles Area Chamber of Commerce, Los Angeles County Business Federation, and Los Angeles County Economic Development Corporation. These organizations together represent almost 400,000 businesses in Southern California and employ almost 4 million employees in Southern California. This is truly an honor for us to have such a representation, such important, prominent organizations that understand and are recognize the importance of what we are trying to do, educating the business community on importance of our being resilient. In particular, at this time, I am really enthused to introduce to you our program champion for today's episode, the California Manufacturers and Technology Association. This is an organization that represents all of the prominent manufacturing and technology organizations in the state of California. The most important engines of our manufacturing here in California. In particular, I want to thank their leadership, Lance Hastings and Gino DiCaro. Lance is going to be on the program later today, but Gino DiCaro, who really early on came on board and recognized the importance of why it is important for our businesses to look at resiliency as part of their business plan. Really, for me, I want to commend them for their leadership. Again, with all of other things that are so important in the state, that manufacturers and technology organizations have to deal with, like many issues, power, all the pandemic, all the big issues, but they still recognize the fact that resiliency is important and the time is now. This is when we have to plan for the future. With that, I want to turn this back to Evan, and Evan will tell us more about the Resilience Advantage webinar series today. Thank you, Evan.
Hey, thanks, Ali. I really appreciate what you had to say, and of course, your support for all of us. So the Resilience Advantage series, for those of you that haven't attended the past two episodes, includes 20-minute videos featuring interviews with experts from around the nation on building design, business, public policy, law, and finance, who will all give their perspectives on the advantages of making resilience as important to the built environment as, say, green design has become over the past 30 years. And then each episode will be followed by a live stream Q&A with these and other experts. In this episode, we're going to drill down into how the decision is made to incorporate resilience into the design of new buildings. Sometimes the decision is made by the owner as part of the project's specifications and requirements. Other times, its genesis just comes through the thoughtful engineering and architectural design of the design professionals. But regardless, resilience is successfully integrated into the design when the entire project team and the building owner or users collaborate from early on to create a successful project. We'll also hear from our panelists following the episode about how businesses and institutional owners are considering resilience as part of their long-term strategic thinking. So with that, I'm pleased to present this episode of the Resilience Advantage, the benefits of resilient design and new construction.
Welcome to the Resilience Advantage, a series brought to you by the U.S. Resiliency Council and Optimum Seismic. I'm your host, Evan Reese, and we're exploring what resilience means to our communities in the face of natural disasters like earthquakes, hurricanes, floods, wildfire, and now even pandemic. In this episode, we'll discuss the social and economic benefits of designing new buildings to not only be safe during natural hazard events, but to limit damage and recovery time. It's essential to the resilience of a community, a business, or a family that the buildings in which we live and work are built in a way that allows them to resume operations as quickly as possible. We refer to this as functional recovery. We'll talk to design professionals and owners who've incorporated resilience into the design and construction of new buildings. And we will show you how affordable resilient design can actually be. Building owners are achieving immediate returns on investment as their buildings are being rewarded for resilient design. And they are protecting their assets and business income against the big one, when, not if, it hits. Recapping from our first episode, structural engineering experts talked about the limited objectives of building codes and the misconception that buildings built to modern codes are earthquake and disaster proof.
That's the problem throughout the Western world. The building codes are all based on a premise of providing life safety, not damage-free. Now, most of the public and our architectural colleagues believe when they hire a competent structural engineer and get a building designed to code, quote, are getting an earthquake-proof building. And that's not what the profession is delivering.
We also introduced the concept of performance-based design in engineering, an approach that allows engineers to design buildings that deliver more than just life safety.
So the biggest innovation, the thing that's going on, is our ability to directly model performance in buildings. Like, we can take real earthquakes, build virtual buildings, and shake them, see what happens, predict like where they break, how they break. So 20 years ago, all the design objectives were around like safety. We kind of like solved the primary problem, which is don't kill anybody. But then now we have all these kind of secondary problems, which is like day after the earthquake, I can't get back in my building. Day after the earthquake, I don't have a place to live or I don't have a place to work. All of those issues are those are the ones that are left. So once you can describe building behavior and risk in terms of like basic understandable phenomena, damage, downtime, and safety, then owners now are just as empowered as engineers. Owners can get it. Owners can decide for themselves what they want, what they can afford, what they choose to pay for, how they allocate resources.
In hundreds of projects in places at risk of earthquakes in the US and around the world, structural engineers and architects are using performance-based design to deliver resilient buildings to clients in both the public and private sectors. Clients are investing in resilience as a way to protect their investment, their business, the livelihoods of their employees, and the services they provide to their customers. Projects are successful when the entire design team works with the owner or users of the building from the beginning of the project to incorporate resilience features into the building. In 2015, the state of Oregon decided to construct a new 2-story facility to house its Treasury Department. The critical work Treasury employees do every day to manage the state's money and ensure payments are timely made can't stop when there's a disaster. Whether wildfires, volcanoes, or a magnitude 9 mega earthquake in the Cascadia subduction zone, the Treasury building needs to remain operational during and after an event. The state developed criteria the new Treasury building would have to meet in order to be confident it would function uninterrupted after a major natural disaster. They required that the building be designed to meet the U.S. Resiliency Council's highest standard of performance, a platinum rating. I talked with several members of the project's design team and with the Treasury Department about why resilience was important to the state for this project and how it was successfully integrated into the design. So let's start off maybe talking a little bit about the genesis of this project. Byron, why did the state feel it needed a new Treasury building? Who's going to work in the building? And why does the state consider it to be sort of an essential type facility?
So about 6 years ago, there started to be a lot more press in Oregon regarding the risks to Oregonians from a Cascadia earthquake. And prior to that, a lot of people didn't really think of Oregon as a high earthquake risk area. The treasurer is a statewide elected official that's responsible for overseeing the state's banking, debt management, and investment activities. And so in this last year, we processed just almost $300 billion in banking transactions on behalf of the state. We need to, on a day-to-day basis, make sure we are providing those critical functions to Oregonians.
One of the things that we've been talking about in this series is how building codes, even modern building codes, codes that we use today to design typical buildings, are primarily designed for life safety. But then also in the event of a large natural disaster, whether it's an earthquake or a hurricane, that the building will be safe. But not necessarily damage-free. Buildings that are built to sort of the minimum requirements of the code might suffer significant damage. Maybe they won't be economical to repair. Maybe it will take months or years even for them to be repaired if they are.
So when we first started looking at this, our initial analysis was looking at our current building and what does it take to make this building more functional for what we needed going forward. And as we started looking at that and doing the risk assessment, it's really when we started to realize the level of risk that we had in the current building. It wasn't just about making sure we had a building built to building codes or that it was built to the building codes for an essential facility. We wanted to make sure that we were getting to that immediate occupancy and operational level and making sure that it wasn't just that life safety, that our staff were safe. The impacts to Oregonians, if we were to have to go a month without sending out banking activities, would be catastrophic on its own.
Craig, as a full team of architects, structural engineers, but also mechanical, electrical engineers, how did you sort of establish that kind of communications back and forth with Byron and his team that had to talk about these issues of performance and how that might affect the design of the building?
Well, it started with a lot of good planning, and GluMAC engineers and KPFF structural engineers were involved maybe a year prior to GBD. When we formalized the team, we came on board, we got the entire team, all the stakeholders, not just the major designers, but civil and landscape and acoustical engineers, and talked about expectations. And out of the gate, the driving guiding principle, number one, was USRC Platinum, a building that could be readily reoccupiable after a major Cascadian quake without significant damage.
That's wonderful. So Reed, let's talk nuts and bolts here, or beams and columns. How did you design this building? What is its structural system? How would that maybe be different from sort of an ordinary office building, that might be in downtown Portland or something like that?
In the early stages of the process, we actually looked and worked together to look at different solutions. The first being creating a lateral force resisting system, the part of the structure that resists earthquake and also wind, building it out of a buckling restraining brace frame, which is a common lateral force resisting system type for steel frame buildings. And what we were finding when we started evaluating it against the USRC metrics, specifically safety, damage, and recovery, is that it had a hard time meeting that recovery dimension. And safety, obviously extremely important, and reducing the damage in a building is a key point. But when we're talking about resilience, we have found that a lot of times the discussion starts to center really more around recovery. And it's quite actually, I won't say easy, but straightforward to design a structure, meaning the portion of the structure, the portion of the building that is composed of beams and columns, not the things in it, for a very high performance level.
So how important is it to the whole design team that all of these discussions are laid out, the expectations for the building, and that everybody sort of have a seat at the table in the beginning so that the project is proceeding in a way that doesn't cause unexpected, challenges?
Well, we did start out with all the key stakeholders I alluded to in the room at the same time. We all put out what our goals were, and the base isolation and the USRC Platinum was really easy to work towards once we knew that was a prerequisite, essentially. And being able to know that really day one made our process much more efficient. We would have needed to go really back to the drawing board if we had found out that later in the design process, because it affects every discipline in the building.
So Byron, you talked about this a little bit in the beginning, but what are the kinds of payoffs that the state believes it's going to be getting from having this Treasury building be resilient, be base isolated, be operational, even after that mega quake?
I think for us, it's really about making sure that we are providing the services that are necessary and expected from our team. That we realize that we serve a critical function in the state that often is invisible to people. You don't think about it. I like to use, with my team, I use the analogy of, I say we're the wheels on the bus. Nobody thinks about the wheels on the school bus until they fall off. And then everybody's really upset that they fell off.
Well, I don't think any of us is unaware now about manufacturing PPE or ventilators or the process for producing vaccines, something that we all have intended to, we've all essentially ignored for most of our lives. And now, you see when it's needed, it comes to the forefront. Craig, the state brought the contractor in early on in the project during the design phase when they brought you in. Sometimes on a project, the design team works together, they get the whole project done, they get the drawings completed, and then it goes out to bid, and the first time a contractor sees it is when it's presumably all done from the design perspective. So having the contractor in early specifically to help figure out costs so that they could, dynamically determine kind of what in the wish list they could keep in the building. How did that process go for you and the design team working with a contractor early on in the project?
It was a welcomed process, especially with Pence Construction. They were a team member from the very beginning. Although the property owner went out to several contractors, they selected from the most competitive and most qualified contractor. We worked with them closely throughout the design process. They gave us feedback, they listened in, they went back to their sub-consultants and were able to comment on the design process throughout and talking about getting us the biggest bang for the buck as far as design features and what were practical and something that we could afford.
So Reed, what were some of the lessons you learned in this project? In particular, about the role the structural engineer has in ensuring a successful and resilient design.
I think the role of the structural engineer as an advisor to the owner and to the architect is something that is very important and a critical role that we can serve as structural engineers and as sort of resilience professionals. Oftentimes we have the technical capabilities and both to solve the problems, but not always to communicate them. And I think that it's important that really nothing can be done, a project like this, and resilience in general can't be achieved in a silo. It's very much not just about the structure. And it's not even just about what the structure can do to protect the non-structural elements. As both Craig and Byron have talked about, it's everything. It's the whole package in order to get to that resilience end goal. And I think one of the lessons that we can learn from this project is the benefit of bringing everyone together and having everyone engaged towards a central guiding principle.
Let's turn to a different kind of building with a different tenant population. Housing is a critical element in the ability of our communities to bounce back and recover after a natural disaster. What can performance-based design do for preserving housing, including our most vulnerable populations? I talked to Lori Schumann, Director of Climate Change, Risk Reduction, Resiliency, and Housing at Enterprise Community Partners, about why it's so important to address housing.
What we always want to do is keep people in their home. And on the same token, what we always want to do is mitigate risk to these homes. Because again, we know once a person's out of their home and displaced, it's very hard to come back. It's very hard to repair it. It's much more expensive. And so we see this again and again throughout the nation, whether it's up in Paradise, whether it's on a reservation, whether it's in the Keys, that housing must be preserved in order to keep the communities together.
As difficult as it'll be for individuals who have to live through this kind of hardship, it's even more difficult to imagine the effects on a community scale. A 2019 article in the Los Angeles Times predicted that a large earthquake in the LA Basin or the San Francisco Bay Area could leave more than 250,000 residents without habitable homes. Henry Burton is a professor of structural engineering at UCLA and has been studying how cities can measure the benefits of resilient design, particularly as it relates to housing.
Going back to this theme of our building codes and the focus on safety, but if we don't focus on usability or repairability, that could be a potential scenario, meaning you have a major earthquake in an urban center like Los Angeles, where we don't expect the number of fatalities to be very high, but you could foresee a situation where a large or some percentage of the population are not able to reoccupy their homes after the earthquake. And in that case, they'll look to temporary shelter. And if there's a strain on sort of the temporary housing that the city is providing, then you will have some percentage of what we call out-migration, meaning some fraction of the population that permanently leaves the city.
In a previous episode, we met David Marr, a structural engineer in Berkeley, California. His firm recently completed an apartment building, Casa Adelante, that will provide the highest levels of performance for low-income seniors in San Francisco. I had the chance to catch up with David about that project at the National Earthquake Conference in San Diego last spring.
It's a 9-story building. It's 100% affordable housing designated for seniors. 25% of the units are designated for formerly homeless.
I think seniors are, by definition, resilient. They've lived many, many, many years, had many, many struggles. We know that the stories, the individual stories of these seniors, there's a lot of strength there. And they're still, at that age, they're still facing big hurdles because most of them were afraid of being displaced like many other people had been here in this neighborhood. It's really important that we take care of them and provide them with the housing to live with dignity.
And so this building is for seniors, not only so that we can care for them as they age in place, but so that we can provide a stable platform from which they can continue to lead the city, and we're deeply appreciative of that.
If you think of the population, the folks in this building, they don't have extra money, they can't go to hotels after an earthquake. And so the dynamic here is that there's a both kind of need, opportunity to make a building that's more resilient, that allows folks to kind of stay in their homes while repairs are happening.
And what did you do to make this building more resilient?
We collaborated with a professor from New Zealand, Jeff Rogers. He fabricated and developed this lead extrusion damper for us, and we embedded the damper kind of in the foundation. So when the walls take the big earthquake hit, the foundation rocks, the damper gets activated, energy comes out, and then the weight of the building helps recenter it. It's exactly a shock absorber. I mean, same like technologies that you have in cars, and since you have springs, shock absorbers, and then a bumpy road, you got an earthquake. You got an earthquake, which is the bumpy road, and then building has stiffness and building has energy absorption.
So in terms of performance, how do you expect this building to behave in an earthquake?
So the performance expectations are that the structure is going to be fine. The structural damage will be sort of limited and repairable, and won't impede people staying in the building. We want to be able to keep people in their homes while repairs are going on.
David told me that the additional cost of installing the dampers in the building to improve its performance cost only about $100,000 on a $42 million project.
The number is like 0.24% extra. Early on, we're working with the developers. We did initial studies where we had the promise of cost neutral, then got green lighted to try the performance-based design, and then worked really hard to keep to the cost neutral. So the developers are happy that they think this is a worthwhile investment.
Casa Adelante recently held a virtual grand opening to celebrate the completion of the project. The developer praised the design team, specifically mentioning the structural engineer and the value of the USRC rating that the building received.
We and the entire team are really excited to do innovation and resilience for affordable housing. We're super excited with the results. This is the first project to receive a gold rating from the U.S. Resilience Council. We feel that it's a great precedent for achieving low-cost resilience, and we hope it's the first of many to come.
So, for an additional 0.25% investment in the construction, Casa Adelante went from an ordinary building to one that means the city will not have to provide additional shelter space to house its occupants after a repeat of the 1906 earthquake. One thing we know about the occurrence of natural disasters, it's a matter of when, not if. As long as we build in areas prone to earthquakes, hurricanes, wildfires, floods, or other hazards, we must accept the reality that one day our structures will be tested. And if they fail to meet that test, it will cost lives and also livelihoods. The buildings we profiled were designed to achieve resilient performance beyond the minimum requirements of the building code. The return on investment can be high. For the Oregon Treasury building, the state can count on the building remaining operational during those critical hours and days following a mega quake. The collaboration of the design team with the developer, the user, and the contractor was essential in creating a design that was both affordable and which would achieve the state's objectives. For Casa Adelante, the return is in the bank. When the big one hits, the city of San Francisco will have the confidence that its residents will have a safe place to stay, reducing the demands on the city's emergency services. And the apartment's owner will be able to maintain its source of income. It took decades for car manufacturers to put seatbelts in their automobiles, and decades more to put in airbags. But now no one would even consider buying one that didn't have both. Each time we decide to construct a new building, we have the opportunity to make our businesses and our communities stronger, safer, and better able to recover from natural hazard events. Building resiliently is good business. A small investment now, sometimes it means just writing earthquake performance goals into your project requirements and hiring an engineer who understands performance-based design, can protect your most precious and valuable assets, the continuity of your business, and contribute to the welfare of your employees, your residents, and the region. Next time on the Resilience Advantage, we'll consider how our communities benefit from resilient design, preserving both the social fabric of the places we call home and the financial stability that drive our economic vitality. We'll discuss how both the public and private sector are making resilience happen in cities across California, and what type of incentives are being offered to make resilient design a reality. Thank you for watching, and please join us next time on the Resilience Advantage.
All right. Well, thank you. I hope you enjoyed that episode as much as we had fun in producing it. Now we're going to move to the Q&A portion with our panelists, who I'll introduce. For those of you watching, there should be a chat box that you have access to. Feel free to type in some questions, and we'll get to as many as we can. So with that, I'm very pleased to introduce our four panelists for today. Lance Hastings, who Ali noted, is the Executive Director of the California Manufacturing and Technology Association, and his group is our champion for this episode. So Lance, thank you very much for joining us. We also have David Marr, a structural engineer who you saw in the video, who's the owner of Marr Structural Design in Berkeley. And Craig Stockbridge, again, who you also saw, who is a principal with GBD Architects up in Oregon. And we're also pleased to have with us today an old friend of mine, Marianne Phipps, a structural engineer and president of eStructure in Oakland, California, who's done a lot of great work with institutions and organizations in the Bay Area for several years. So thank you all. Welcome for joining us. So let me just sort of kick it off and start with some questions. Let me start with you, Lance. First of all, again, thank you for the CMTA hosting our event today. We appreciate it. Maybe you can tell us a little bit about your organization, who it represents, and what kinds of buildings and facilities your members typically use and own. Oh, I think there you go.
Okay, thank you very much for the opportunity to participate today. We really appreciate it. So CMTA is a trade organization that, interestingly, organized 103 years ago in Oakland, California. So no stranger to the Bay Area with all of its seismic activity. And we're now in Sacramento, California. And currently we're actually housed in one of the oldest historic buildings in all of Sacramento, the old Senator Hotel office building, which itself is a cinder block building that's been reinforced over the years. So it's always top of mind. And when Ali came to us several months ago, we started chatting about the synergies between making sure that California businesses and buildings are resilient, prepared, and ready for an eventual earthquake. And having grown up in the Bay Area myself on the Hayward Fault, it's not a matter of when it's not a matter of if, it is a matter of when. So with our manufacturing facilities up and down the state, there's over 30,000 manufacturers and over 1.3 million employees in our sector. It's really important for us to make sure that we're able to protect not only the buildings, but certainly employee safety, and then the capital investment that's been made for all of the machinery within those buildings. So for us, it's really a good connection. It's important for manufacturers to be prepared and resilient in the case of a natural disaster of any variety, because we are an economic driver for the state of California, and we need to continue so.
Thanks, Lance. So, so of course, manufacturing, maintaining functionality operations, obviously it's key. I mean, there's a lot of these plants, that your members use are operating 24/7. That's where their revenue comes from directly, is making the stuff. So, so can you tell us a little bit about why resilience is so important in protecting the operations, but also the inventory, and there must be complex equipment in a lot of these buildings. Why is that so important to your members?
Well, it's all important. I mean, every bit of a moment of downtime that's not planned for maintenance is a loss. And if it's aggregated across an entire geography, for example, in Southern California, the impact of that is tremendous. And again, sometimes the value of what's contained within the walls and underneath the roof is more valuable than the walls and the roof. And that doesn't even speak to the employee value that's present. So in order to ensure all of that is protected, having some kind of advanced plan in preparation for an event, but certainly the resiliency plan after the fact, it's mission critical. And I know we're in the middle of a pandemic at the moment, trying to see that through. And early on, that there were some pundits that saying, well, all California needs right now is an earthquake, to be the trifecta, which obviously we don't. But the ability to prepare for that, because it goes back to the when, not if, and to be prepared for that is really, really important. And this connection with Optimum Seismic has been helpful with our industry sector for, if nothing else, to raise the issue so that we can have a thoughtful debate about it and be prepared as a result.
Oh, wonderful. Thanks, Lance. So, David Marr, let's, first of all, congratulations on the successful completion of Casa Adelante. What a wonderful project in so many ways. I'd like to take a step back for just a minute, and maybe you can tell the audience a little bit about what it is that causes the damage to buildings in earthquakes. When you are trying to understand the performance, what things are you looking at that actually result in the damage to buildings and everything that's in them?
Well, to me, the elephant in the room is that the code intends the structure to be damaged. I mean, it's by design. The plan is to take the expensive the bones of the building and break them. And the building sacrifices itself to keep people alive, for safety. And it's traditional ductile design. It's what we plan for. And then along the way, the rest of the building, the architecture, everything that's connected to the structure, also gets damaged with the movement. And it's an unfortunate sort of legacy of an efficient strategy to save lives. And I just think that it's important to look at how we can do better as a sort of building and design community by being able to sort of move on beyond sort of this expected damage process and say, well, how do we figure out how to design buildings that are safe and we can avoid damage?
Yeah, that's great. Yeah, I mean, I guess, most people think about cars, and, the goal of a car when you get into an accident is to have it just keep you safe, keep you from the hospital. But it doesn't really take much for a car to be a total loss in an accident, even though it keeps you safe. It's the consequences are so much larger when it comes to a building. And all the people that are in it, all the functions that go on, all the services it provide, that the value of it as an asset to the owner. And if we have the same mentality of the only purpose of a building, only purpose of the structure is to keep people alive, then we miss out on this real loss beyond that can occur.
Right.
So Marianne, thank you for joining us. I'd like to talk with you a little bit about your work and maybe some of the things that most people don't think too much about when it comes to a building, which is all the non-structural stuff. So first, why don't you just introduce yourself, tell us a little bit about your background, and the kinds of clients that you work with on a daily basis.
All right. Well, I am a practicing structural engineer, and I've spent most of my career working in the healthcare industry and mostly on hospitals, and both designing new hospitals and renovating hospitals. And in the state of California, hospitals are designed to remain operational after a large earthquake. And that means I've spent most of my career thinking about all of the things that go in and on the hospital building, and focusing on how to make them continue to function after an earthquake so the building can be occupied and be available to serve all of the community. So that's kind of my background, and it's forced me from a real grassroots kind of hands-on level to understand the architectural systems, the cladding and the ceiling and the partitions and all the mechanical, electrical, plumbing, sprinklers, all of those systems to understand how they each operate and how they operate together. Chased earthquakes on this, studied what happens in earthquakes, done some research on it. So I've really dug into the sort of the non-structural side. And over the past decade or so, I've translated a lot of this sort of knowledge that I've gained through the hospital design and brought it to bear on other institutional clients. I work mostly I do a lot of work at UCSF, large campus of buildings, many campuses of all kinds of buildings. I chair their seismic review board. I work on the CSU, for the CSU system on their board, UC Berkeley, the state of California, UC system. So I'm bringing that to bear on large institutional clients on a building by building basis with peer review and on a larger scale with policy and guidelines.
That's wonderful. Yeah, Marianne and I have known each other for several years, and she also, by the way, was president of our Structural Engineers Association for many years as well. So, Marianne, you mentioned something that I think is really important for people to understand, and that is that a lot of a building is not the structure itself, not the walls, not the beams and columns. In fact, I've heard numbers around like 80% of the cost of a building might be associated with the other stuff, with everything that people see and use, the partitions, the ceilings, the windows, the mechanical equipment, the elevators, things like that. And so I imagine if 80% of a building's cost might be in these non-structural things, focusing only on the structure and making the beams bigger or the columns bigger can not necessarily address all the things that cause building damage. And of course, it's those other elements, I mean, the cladding for the building, the thing that protects you from the rain and the wind, or the elevators in a multi-story building where you can't really use the building if you can only use the stairs, or a building that doesn't have water because the pipes break. So can you talk a little bit about how those kinds of elements suffer damage in earthquakes, but also how they can be made more resilient in the design?
Well, you're absolutely right. Most earthquake damage in buildings in the United States, where we've got good building codes, will be non-structural. And non-structural elements are damaged even in small earthquakes. So the threshold is greater. And a lot of small earthquakes, the structure is not going to feel very much or have any damage, yet non-structural components will be damaged. And there are things we can do about that. The best example that I have, just to drive the point home, was from the Napa earthquake. This was a 2014 magnitude 6, so not a very big earthquake. And I went there as a representative of FEMA, and with a team, we looked at every building within 1,000 feet of downtown Napa. And we went to see what happened in every building. And the building I will never forget is the County Services Building, which was a generic concrete shear wall, 1950s building. The structure had absolutely no damage, but there was one sprinkler head just below the roof that sheared at the ceiling. And that earthquake happened at 3:30 a.m. The water was pouring out because, of course, sprinkler lines have water under pressure. Water is pouring out. The building was closed for 6 months because one sprinkler head broke. So a couple of lessons there. First, worry about your sprinkler lines. The things that you can do to prevent sprinkler damage, for example, is you have a flexible line between the branch line and the sprinkler head so that when the ceiling moves, it doesn't just shear off the head. But that's the kind of thinking that goes into the design process. You want to think about the consequences of damage, what you can accept or what you can't accept, and then work to detail these systems properly to limit the damage to what's acceptable to you.
Thanks, Marianne. That's I really appreciate that response. So, Craig, you're an architect, and so you get to deal with all the disciplines on a project. You're working with structural engineers, mechanical engineers, a large group on the design team, and of course, you see a lot of what Marianne just spoke about, how the non-structural elements go together to make the building usable, what it looks like, etc. And by the way, congratulations on the Oregon Treasury building. I wish you a smooth construction process. But can you expand a little bit from the video on how the other disciplines, say beyond just the structural engineer, were engaged with you on this project to ensure that all the non-structural systems were also resilient?
Yeah, absolutely. And just a little bit of background here. I feel like I'm in great company with all the experts on earthquakes, especially in Southern California. Earthquakes in Oregon weren't really even mentioned about 10 years ago. And then as the report came out a couple of years ago, that pretty much put the fear of God in all of us that the big one is coming. The last big one was 330 years ago, and they're predicted to happen every 250 years, at least these cascading subduction zone quakes. So that really motivated us quickly. So we quickly became, or trying to become, more and more often experts on earthquakes and predicting them and how we resist them. So if we think about from the beginning where the ground is shaking violently and our building is isolated, so it's decoupled. So what happens with all those utilities, the dry and wet utilities that are coming into the building, and our building is now, again, pretty much staying isolated where the ground is shaking up to maybe 3 feet, 18 inches in each direction. So you can see that those connections being very, very critical. One of the things that we debated is whether we bring in natural gas to our building. Would that be more of an asset or a threat? And at the end of the day, we decided that was one less threat that we wanted to avoid. So although all our connections to utilities are very flexible, again, we decided to pass on the natural gas option at this time and to save that one for a later conversation. But you think about all the other elements, non-structural elements in the building, and how they become potential threats. So even though our building's isolated, it's more on a kind of a rocking ship is how it's been simulated with our structural engineers. Can you imagine a nice decorative pendant light in our lobby swaying around, potentially doing more damage? So, and all of a sudden that starts to rethink how we approach lighting, and actually every discipline with that resiliency lens.
Great. Well, as an architect that has, I'm sure done many projects that have been focused on green design with LEED. I'm sure that's been part of, many of your projects over the past, say, 20 years. How do you think resilience is becoming more important generally on projects as 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 we continue to see nationwide, worldwide, the impacts that disasters can have on whole communities and businesses and families?
It's definitely the next generation of sustainability has now evolved into resiliency, where sustainability is minimizing our impact on nature, and resiliency is really resisting nature and other forces. And so those hand in hand seem to make a lot of sense. There was some comments made about buildings have been seen as disposable in the past, and we realize that we need to be thinking about that differently, and we have the technology to do it in a very cost-effective way. So it definitely reminds me of the sustainable and LEED movement that happened about 20 years ago when that started here in Portland, and many of our buildings are absolutely must be LEED. LEED has seemed to be more incorporated into our building codes, and there's less discussion about it. It's still important. Getting that plaque on the wall is maybe not necessary. Most of our clients in the private sector, but resiliency is the next discussion and has been very much at the forefront for the last few years.
Right. So, David, when we think of green design, we often think of it being sort of aspirational, right? We know that it's good for the environment to use less materials, to produce less waste, but it's not always easy to quantify that. But with performance-based design, which we've been talking about in the past couple of episodes, part of the goal is to quantify certain metrics, like what it'll cost to repair a building after an earthquake, how long it'll be out of operation, days, hours, weeks. How do engineers now, what kind of technologies are available to help you do that actual quantification of the benefits of performance-based design?
Well, we're in a super exciting time with the advent of FEMA P58, which is I always think of it as like the missing link in the performance-based design story. I mean, on the structural side, we can quantify what a building will do, but what FEMA P58 did, it allowed the sort of modeling of all the structural and non-structural stuff, and the modeling of damage potential and repair cost and repair time. And so once we've sort of coupled the structural model with the economic model, we can then sort of bring all of the analytical power to bear to be able to tell the story to owners about like what something will cost if it's damaged, and how long it will be out of commission. And that sets up this sort of wonderful open conversation about the nature of design. What do you invest in? What do you expect to achieve? And suddenly the whole world is opening up because of this ability to kind of quantify and predict what's going to happen.
Thank you. So we got a couple questions from the audience for you, David. One relates to, first of all, what the relationship between resilience and the site conditions might be. Does where the building is and the kind of ground that it's on affect its resilience?
Yeah, I mean, I think of the site as sort of almost like the DNA of the future building. It's like your parents' genes, and for the project that the Casa Adelante, we had a really tough site, and so there had to be a lot of investment into site mitigation. But the site in a sense is another structure, and there's a coupling of the site structure or the ground characteristics with the building characteristics, and kind of getting those initial relationships right sets up a lot of the either the cost or the cost effectiveness of the future design. So the site is a huge driver and consideration.
Okay. And we had one more question for you right now, which is on the dampers themselves that you used. One of our listeners or viewers was wondering, are those designed to resist vertical accelerations, or are they designed to help mitigate the side-to-side lateral shaking of the building?
They're activated through the lateral movement. So it's when the shear walls take lateral loads, they rock, and that induces the sort of vertical action in the damper. So they're designed for lateral resistance.
Right. Sort of like pushing a bookcase over. If you push a bookcase horizontally, one end tends to tip up vertically,
Absolutely.
And that's what you're trying to hold down. Great.
Yeah.
So, Lance, I want to ask you a question about a project that we're actually going to be talking about in a later episode, but on retrofit. But it really has to do with sort of new design and manufacturing as well. In one of our previous episodes, we sort of introduced this, that Anheuser-Busch, which is obviously a big manufacturing company, has had a plant in Van Nuys or in Southern California for many years. It was actually hit by two big earthquakes, the 1971 San Fernando earthquake, and I believe the 1994 Northridge earthquake. The first time, that was a big wake-up call for them. The building had to shut down. They had to shut down production. They didn't want that to happen the next time there was an earthquake. And of course, it's Los Angeles, so you know there's going to be one. They spent millions of dollars actually retrofitting their existing plant, but also designing new facilities. And then when Northridge did hit in 1994, it suffered much less damage than would have happened had they done nothing. In fact, I've heard some estimates that when it comes to business interruption loss and the asset losses itself and all of the revenue generated, that it might have saved over $1 billion in total losses. So maybe you could talk a little bit about the lessons that manufacturers have learned or can learn from the experience that Anheuser-Busch did in not wanting to suffer the same kind of damage in future earthquakes that they had experienced in the past.
Yeah, well, thanks for the question. I mean, it's all about preparation, and an ounce of prevention is worth a pound of cure. I mean, I think a lot of cliches apply to this, but it's one of the things that as Californians we really can't ignore. I mean, earthquakes are throughout our history, will continue to be, in our ability to manage that. And I think it's an important narrative to break down the construction of the building. And what that means, and the innards, if you will. Marion made a good point about some of the damages are unrelated to the structural part. The building will still be there, but nothing inside is going to work. So resiliency is really with a capital R, and kind of how we look across the entire spectrum. And Anheuser-Busch, they have two breweries in California. One's up here in Northern California, in Fairfield, which, yes, we're still in earthquake territory, but not as much. And their ability and their pre-planning, I think, will protect them into the future. So if nothing else, there's a story here that can be shared and echoed across the manufacturing sector, because the complications of a bottling facility and a brewing facility, a lot of machinery is involved there to get the beer into the bottles or the cans. And they've been able to get ahead of the curve and plan against current and future events, and really to be applauded. And to the extent we can herald their example would be great. And I'd just like to use another example of there wasn't earthquake damage as much to one of our manufacturers up in the Sierras down south in the Bishop area, but Searles Valley Minerals was out of business, not because of their building structure was hit so much as that the town water supply was cut off. And absent that, through the earthquake that a couple of, now a year and a half ago, can create huge havoc. So resiliency is not only for site specific per se, but it's region specific. And we're only as strong as our weakest link. And if it happens to be a water pipeline that is broken during an earthquake, well, that's going to impact an entire community. So I'm glad that you guys have raised the Anheuser-Busch issue. It's an important one I think we could all learn from. And to the extent that you focus on that in future webinars, I think that'll be fantastic, because there's a lot to learn there.
Great. Yeah, thank you. And I'm going to ask Marianne a follow-up question about this. This idea, you mentioned the externalities. There are things that obviously the owner of a building can't control, but they have to work with the city or the community around them to make sure that vital utilities and services are provided. Marianne, you do a lot of work. You mentioned a lot of work with universities, which are, in some ways small cities themselves, right? They have all the different functions that a city has, from housing to food to, office space and classroom space, and, even police, fire, and medical. So, when it comes to working with an organization, say like UC San Francisco, okay, how do they think about resilience, not just on an individual building, but, for the continuity of the whole campus and the ability to provide all the different services they do for thousands of people that live and work on that campus?
Right. Well, it is a complex undertaking to just even begin. And I think where UCSF started was to really think about what the consequences would be of being out of certain buildings, to begin to establish sort of tiered priorities. And what they realized, one of the things they realized, was that the assets that reside in their research laboratories are sort of, let's say, irreplaceable. That is, there are generations of specimens and bloodlines and research in animals, fish, and mice that goes on literally for generations, that if they're lost, they are truly irreplaceable. And this is the kind of research that, they're trying to cure the currently incurable diseases. So the loss of these strains or these specimens is really unacceptable. Not to mention the loss of the researcher, because if the researcher can't get in their lab, well, they're going to go to another institution. So keeping research labs, the downtime associated with research labs small is very important. They need to be able to get back in there and continue to work and get the work done. So that was one thing they realized. And then also surveying their needs, student housing. If the students don't have a place to live, well, you're no longer an academic institution. And so housing, they recognize, as was discussed earlier with David Marr, the need to continue to house students after an earthquake is very important. And so they began, but on the other hand, offices, as we've all learned, maybe not as important to keep operational after an earthquake, because there are other options for how we can work. So UCSF created 3 tiers of performance. Tier 1, the lowest level, is what we'll call good code or code plus, where we design a good building that meets the code, but structurally it's really thoughtfully done. So to consider regularity and the kinds of systems that one uses, but just a good code building with enhanced non-structural performance. So paying much greater attention to what goes in and on the building so that it will have a better chance of withstanding earthquakes, but not going way overboard, just doing it thoughtfully. What's already required by code, but doing it well. The next tier is to really get into thinking about recovery time, how long they could be out of a building, or how quickly they need to get back in, and then explicitly designing, thinking about damage and repair and how quickly that can be done. And then the third tier would be more like a hospital, where the level of damage is really limited and you have to be able to go in there and operate fully right after an earthquake. So they established these 3 tiers, and then each project that comes up, the first discussion is, what is our aspirational goal? And then once that's established, the entire design construction team is focused on the decisions that get made at every step of the way for how to achieve the goals and the performance objectives that have been established.
Okay, so that probably took a lot of effort on UCSF's part and other universities like UC Berkeley just to even establish this process. It sounds very complicated, but very important to have this established process going forward, from what the performance of a building should be to how the design team interacts during the design. So if you were to give some advice, say, to a university, or it could even be a large corporation that has either a lot of office space and multiple buildings, or a manufacturing a company that has a lot of buildings on a campus, what would be some first steps for them to start this process of developing these long-term strategies?
Yeah, and I think it's good to ground this in reality and not suggest that this is simple. It's a long-term investment and process. I think first and foremost is there needs to be a champion inside the organization that recognizes the importance. Without that, things aren't going to change. And so I don't think you can underestimate how valuable it is to have somebody on the inside who is championing, the resilience. Second thing is to have advisors who support the vision and can talk to these issues. So at UCSF and UC Berkeley and CSU system, each of these organizations and PG&E, which I'm working with now, they all have sort of seismic review committees or seismic review boards, but a group of experts that represent different fields, geotechnical, structural, that come together and help advise on both the policy and guideline level and also on the building by building level. So you can bring in sort of a notion of peer review and good design from the beginning on all these projects. So that's proven to be very helpful, at least in my experiences with these various institutions, and gone a long way to elevating the attention that seismic resilience is getting and deserves.
Great. Thanks, Marianne. Yeah, it is a challenging effort. And I think we need to, one of the things at the U.S. Resiliency Council, one of our mottos is it's fear plus hope and a plan. We have to be aware that we live in earthquake country and we can't avoid the risk. It's there, earthquakes are going to happen, but there are ways. There are ways to address it, and there are ways to do it rationally over time. That doesn't involve just trying to either shut down everything until it's all fixed or go bankrupt trying to fix things, but to work your way towards a solution. Those solutions are there. We're seeing businesses, institutions, large and small, really making that effort. So in our last couple questions, David, I want to ask you sort of the same question I asked Reed Zimmerman in the video. What are a couple of sort of key lessons that structural engineers should keep in mind when trying to incorporate resilience into a new building design, especially, let's say, if it's not called out in the project specifications? The gold rating received for Casa Adelante was not a project requirement, whereas the platinum rating for the Oregon Treasury building was. But what are some lessons you learned and you could contribute to other engineers in thinking about how to raise questions about resilience, how to make it something that people do think about or can be incorporated into a project?
Great question. I see the number one is that cost effectiveness and value have to be a big part of the conversation. You talked about fear, hope, and a plan. Fear's not enough. You can't scare people into resilience. But being able to say resilience and cost and strategy and comparison and competing cost, like in our project, we had to carry the strategy was to carry two competing schemes pretty far into the design process. And in that, we were always checking cost effectiveness and having the contractor run dual models, cost models, because projects are stressed for budgets, and there's competing demands on budgets. And in this case, in the housing environment, we're in an environment where more housing is more important than a single better project. And so our goal was to figure out how could we create the best project with no extra cost. And that's just a kind of the reality of competing demands. So I'd say number one is to as a designer think in terms of cost effectiveness, and then the corollary to that is be able to communicate that with the team and be able to have a narrative that makes sense. And a big part of the narrative on this project was we needed to keep vulnerable people housed. That was, it's a really simple but big idea. And it's a big idea that people could kind of get behind and understand. And it's non-technical. And so being able to take all this sort of technical stuff and break it into messaging and campaigns and advocacy and storytelling in a way that regular folks can get it, I think is essential to having any success.
Thanks, David. Yeah, communication is something that the U.S. Resiliency Council has really worked hard to bridge that divide, if you will, between the technical and the lay audience, if you will. And the audience, when you watch the video, you saw some of these sketches that David and his staff prepared to describe what these dampers do. And it's very easy to see that from those kinds of sketches versus, just the technical output of a computer program. So I hear what you're saying. Craig, I'd like to throw the same question to you. Now, you had mentioned on the video, of course, that the USRC Platinum was part of the specifications for the project, and that gave you and the design team a good roadmap for moving forward with the design. But in the future, there are going to be a lot of projects where obviously it's not specifically identified in the project specifications. How would you see, as an architect who often has sort of the first contact, if you will, with an owner, how would you see the opportunity to introduce concepts of resilience into a project where maybe it's not specifically called out in the specs?
Yeah, interesting. And usually those decisions are made obviously before we get to the table. Marianne was pointing out the kind of this process of what is the priority and what is understandable damage to the building, or is there no damage to the building as an expectation. I think it's one of those things that's almost similar to how we approached sustainability. Lots of people thought as soon as you mention the word LEED, it's going to cost more. Well, if we are just designing it and integrate it into the building, there are elements that may have costs. We can identify those. And there may be items that actually save money. And so similar to resiliency, there would be analysis that would have to go in there, and we could actually probably show them fairly easily with the State Treasury building as a prototype of items that had a cost associated with them or had a payback, and that's maybe the most extreme payback is a little hard for a lot of private developers, especially to pay up front in that first cost. But you can see how this would become more and more common, and especially, and I love that that saying of fear, hope, and a plan. I would say it's, instead of fear, it's more of an awareness. And as we come to understand it, again, it is just a matter of time before this happens. And there are things that we are not willing to lose to us, whether it's life or research or our structure above our heads, that people will become more and more apt to build more resilient buildings.
Well, thank you. So I'm going to ask maybe Marianne sort of one final question. Since you have this relationship with a lot of these sort of larger organizations, and we talked about UC and Cal State, and I know that you mentioned PG&E, and I know that you've worked with some other sort of larger private corporations. What would the message be? And you can use your former Seahawk president hat on this too as well. What would your message be to businesses about why they should be considering resilience right from the get-go in a project, for their projects?
Well, I think it starts with the awareness piece, and that is a matter of thinking about the consequences of earthquake damage that will follow in many cases for buildings designed according to the code. So understanding the potential that the building will be out for an extended period of time and unavailable for use. And think through what that means for your business, your enterprise, your company, and then make decisions about, if that is unacceptable, what you can do about it. So it starts first with the awareness and thinking through the consequences. Once you've done that, then it's a matter of understanding that there are options, and that all options for resilience are not necessarily going to break the bank. And that's the message I think is really important to communicate, which is what part of what this is today is about. And I kind of want to underscore that, because I think some people are afraid of going down this path because all they see are dollar signs. But maybe if I could just share a couple of examples where we already have the one that David Marr talked about, where it was 0.25% or whatever it was. A lot of the times the way we're handling higher performance is not necessarily a stronger building, but a building where the entire design team spends the time to position the lateral elements really well, to detail them a certain way that they can be, that they will be more likely to respond favorably. For example, a shear wall with lots of holes in it has a lot of places that it's going to be damaged and cracked up and potentially small. But a rectangular shear wall that doesn't have any flanges or weird stuff going on does really well if it's detailed nicely. And so if you spend the time up front and commit that you want good performance, and the designers, architects and engineers and owners work together to lay them out, you can get a really nice layout of walls. You can make them all rectangular. You can detail them for ductile response, and you're going to reduce the damage, but you haven't spent a penny more. And you've probably spent less because you've done it more strategically. So that's the kind of thinking that we go through. Or one more, cladding design can be a really expensive part of a project. Sometimes it's better to make the structure a little stiffer, and it reduces the cost of the cladding, and it improves the response of the cladding. So you didn't spend more money, you actually got a better building, and you did it with good design. So that's the message that I think that needs to be infused. And with that message, you can just get more resilient buildings without a lot of money, and just move toward, a better group of buildings in your inventory.
That is a wonderful response, Marianne. I so appreciate you bringing to the fore the idea that just a good collaboration with the design team, respect between all of the disciplines. I'm old enough to have worked on projects where the structural engineer never even meets the owner. You're basically given the layout of the building by the architect, and it's like, here, just make it work for code. So I really appreciate that. I think that that collaborative spirit is something that, I hope we can see more on projects. I did get one last question from the audience, but I think it's something we can save for a future episode. The question was about older buildings like non-ductile concrete and other types of structures, and how risky are those. We actually have a whole episode devoted to retrofit, where we'll be talking about older vulnerable building types like concrete buildings, say built before the late 1970s, and older steel and masonry buildings as well. With that, I think it's clear that what we've seen today is that the choice to incorporate resilience into the design of new buildings needs to be a deliberate one. But it's a decision that can achieve significant returns on what is typically only a small, if any, additional investment. It's essential to decide early on, the very beginning of project planning, that resilience is something you want to pursue, and assemble a design team and construction professionals that can collaborate to make it happen. Resilience is good for business and good for communities. It ensures that livelihoods, housing, and the economic vitality of a region will be protected when the major natural hazard event occurs. As Ali likes to say, earthquakes are inevitable, but disasters don't have to be. I'd love to thank sincerely our panel today, Lance Hastings from the California Manufacturing and Technology Association, who championed this event, David Marr of Marr Structural Design, whose Casa Adelante project is really an inspiration for how resilience can be made accessible and equitable, Craig Stockbridge at GBD Architects for talking to us about how project teams work together to achieve resilience, and Marianne Phipps of eStructure for giving us this perspective on institutions who are incorporating resilience into their overall building strategies. I would like to remind you of a couple of upcoming webinars. We have 8 more after this, but the next one will be February 17th, and it's all going to focus on communities, the benefits of making our communities more resilient. And it'll be sponsored by the California Building Officials and the Long Beach Chamber of Commerce. And then on March 17th, as I mentioned, we're going to have an episode devoted to retrofit and taking older, vulnerable buildings and making them safe, making them usable after a disaster like or a natural hazard event like an earthquake. And the LA County Business Federation and the Los Angeles Conservancy will be sponsors of that organization. So on behalf of the U.S. Resiliency Council, I'd like to thank you all so much for joining us today, and I would just like to turn it over to Ali for a couple of closing comments.
Thank you so much, Evan, for this wonderful program today. We really, really appreciate your great work, your team, and especially this amazing high caliber of experts that you bring together for this series. We really appreciate that. These individuals are, for sure, we recognize them as really the cream of the crop. Thank you so much for your participation, the panelists. I want to thank you to our partners and all of you who are watching us throughout California, the nation, and the world. No matter how far apart we may be, we can join in the quest to make our world safer from natural hazards. We look forward to you becoming part of the growing movement towards resilience. Thank you, and have a wonderful rest of your day.